Okay, in this last video, we're going to take a look at factoring the perfect square trinomials. Uh, and I will have to say, it looks like I have made a mistake here, so we want to get rid of that word difference. Oops. Okay, so factoring the perfect square trinomials. I don't know why I put difference there. So, my bad. So what we're going to go ahead and do is that really it's just an extra step. And so what I'm going to do is just take a play from the other factoring videos that we have. And notice that this is a quadratic that has a 1 out in front, okay? Which means is that that's when a is 1. And so therefore, we're going to go ahead and set this up like the following, okay? Is that we have this 4 right here, and this 4 right here. And again, we ask ourselves these questions. So, what two numbers multiply to 4 and add to 4? So, I'll probably cut to the chase because we're probably getting good at this right now. It's just like 2 and 2 seem reasonable because 2 times 2 is 4, 2 plus 2 is 4. Hey, look at that. We're all good. We set up the parentheses and drop those in. Okay. So now something that I really want to go ahead and bring out is the fact that we have these two are exactly the same. That is x plus 2 times x plus 2. So just like if we were to say x times x is x squared, or we could say 3 times 3 is 3 squared, we can say that x plus 2 times x plus 2 is going to go ahead and give us x plus 2 squared. And this will go ahead and be our final answer. And it's going to be useful later on that we write it like that. It may not seem real clear why we're going to write it right like that right now, but it will. Okay. So let's go ahead and take a look at these next two. Now this next one over here, I have a, which is not 1, and I got a 12, and I got a 9, and all kinds of good stuff. So I want to say, can I factor something out? Okay, so we always got to ask ourselves that question. If a is not 1, can I factor out a common term? So that means is there a number that can go ahead and divide into 4, 12, and 9 evenly? And there's not, unfortunately. Okay, and so what we're going to do is that we're going to move to our next step, and our next step is to multiply the 4 and the 9 together, and that's going to give me x squared minus 12x plus, and let's see, 9 times 4, last time I checked, is 36. Okay, so I'm going to go ahead and do this and say the following. You know what questions are coming. So what two numbers multiply to 36 and add to a negative 12? Okay, so with 36, again, what we're looking at is this business of thinking ahead, is that if something multiplies to something, two numbers multiply to something positive, then add to something negative. Both those numbers have to be negative because a negative times a negative is a positive, and a negative plus a negative is a negative. So let's explore some numbers. Looking at that 1 and 36, and then I go 2 and 18. And let's go ahead and say 4 times 9, which we started off with. And then finally, we got this business of 6 times 6. Now, I know that both of those have to be negative, okay? And when I add them up, they have to be 12. And so if I go negative 6 plus a negative 6, that's going to give me a negative 12. So I know that those are my numbers. So I go x minus 6 and x minus 6 like that. So, but I got to go ahead and I multiply through by that 4. So I have to divide by 4 and then reduce, okay? So this reducing part is going to be 6 over 4 reduces down to 3 over 2, and 6 over 4 reduces down to 3 over 2 once more over here. And we know that if it's still a fraction after it's reduced, we take that number, we put it in front, and we get 2x minus 3 times 2x minus 3. Now, we have the exact same thing again, where these are exactly the same. And so we can combine them up, this, and there we go. That's how we would write our final answer. Okay. And then finally, this negative. Okay. So I look at this and I say to myself, okay, well, I got to factor out that negative first, because it is just a quality of life thing. You want that negative out of there. So I look at here and I'm just like, okay, this is a negative, this is a negative, this is a negative. So when I factor out a negative, it's going to flip all those signs. So all those are going to be positive. So I'd get 25x squared plus 10x plus 1. So now I check. I still got a number in front and say, you know, can I take a number out? Can something divide into a 25, a 10, and a 1 evenly? And the answer is no. Cannot. Okay. And so what I'm going to do is start this process, okay, and start bringing this down, and I get x squared plus 10x plus 25, okay? And now, boy, this question comes up again. What two numbers multiply 25 and add the 10? Pretty straightforward. We can probably say 5 and 5, right? 5 times 5 is 25, 5 plus 5 is 10, okay? So now I go this negative, and I'm going to do this, x plus 5 and x plus 5. But remember, we got to go ahead and divide by that 25 because we multiplied through it for that second step there. And now we got to reduce. So we got this negative, and I'm going to reduce down 5 over 25 into 1/5. And the same thing for that one. And now we can see that we still have a fraction, so this has to shoot out in front of that x. And I'm going to get negative 5x plus 1 times 5x plus 1. And then I package it all together because I have, again, two 5x's plus 1s. And so I put a negative, and now I got a 5x plus 1 to the second power. And there we go. That's my factored solution. So that said, guys, it's just the same thing, except when you have any of these, for each one of them, when you end up with the same thing twice, like right here, right here, right here, you want to write it as a perfect square. Okay, and it will help out later on down the line if you train yourself to write like that. So that's how you do that one, and that concludes our factoring review. Yeah, that's how you do that, and I'll see you in the next video.